Okay, so yeah, it's always something. That's okay. We'll get to use our. We just need to figure out the h for this problem. We could figure. Let's find out k too. Uh, so let's make this. Let's actually have two parts to this. So two questions about each of these. Find the intervals where the function is increasing and decreasing. Find those two different intervals, and then two. Let's get a little bit more practice finding k. We only did it once, and I want to reinforce that a little bit of repetition. So if you feel like you're kind of comfortable with it, so let's look at one. So f of x is 3x squared plus 6x plus 2. I've got some remarks on the far right. I'll come to that when we get to it. So we're going to need to know h no matter what. But the h is negative b over 2a. If it's in this form, like the ax squared plus bx plus c, that's what we've got. So yeah, b is 6, and then 2 times a is 2 times 3, so negative 6 divided by 6 is negative 1 for these very nice numbers. So that's h, and actually, for question number 1, so question 1, that's kind of all we need to know. We know that a is bigger than 0, so it looks like this. It's opening upward. So what happens if it opens upward? So if we've got a parabola that's opening upward, the behavior is always kind of the same. We have this vertex at h comma k. We don't even need to know what k is for this particular problem, which is nice. But we get to h. Well, if it's opening upwards, that means it's a smiley face, which means it's going down before you get to h, and then it's going up after you hit h. So it's going down, then it's going up. H is minus 1, so it increases to the right of the vertex. It hits the bottom, and then it's going up endlessly afterwards, and then it's decreasing on. And that's it for question 1. Question 2. So if it's just an increasing decreasing problem, and that's the entire question, then you're done. You don't have to find k. But this one, I'm asking for k, so let's go ahead and do that as well. So k is just equal to f of h. In this case, h is minus 1. So f of negative 1 is just 3 times negative 1 squared plus 6 times negative 1 plus 2. That 2 is very small. It almost looks like an exponent, but no, it's just a 2 on the ground level. So 3 times, this is 1, because the negative 1 by itself is squared. Adding 6 times negative 1 is the same as subtracting 6. So 5 minus 6 is negative 1 is equal to k. So in this case, the vertex is negative 1 comma negative 1. And it's an upwards opening parabola, which means it's decreasing for x. For all x is starting at all the way from the beginning of time, at minus infinity, it's going down, and then when it gets to minus 1, it hits the lowest it's ever going to get. And then from negative 1 to infinity, you plug in bigger and bigger x values, and you get bigger and bigger y values every time. So let's just do, it's good practice. Let's do this function b and answer questions number 1 and 2. So it's gonna be a similar setup. So need to erase about that much. The process is going to be kind of the same for this here, though. All right, so not sure it was worth saving that little bit, but okay, it's kind of nice though. So for problem B, the function is called g of x. But that function is minus x squared plus 4x plus 4. H is negative b all over 2 times a is negative 1, so negative 4 over negative 2 is positive 2. And that was what we were doing. We were finding h. A is negative, so it's increasing and then it's decreasing because it's opening downward. Here's a summary on the far right. If A is negative, then the vertex is a maximum, which means you're increasing, and then you hit the maximum, then you go down. So increasing from for all x's that are less than h, and then it's like a rock that you throw in the air. It reaches as high as it's ever going to go, and then as well, that's as high as it's going to get because gravity takes over and it starts going down. And then from 2 to infinity, the y value is decreasing. Okay, so question number 2 was what's k? How do we get k? K, we just plug the h value into the function. So g of 2 is the negative from the equation, and then it's 2 squared. So this negative is like outside of the x squared. You take x squared and then the negative of that, and then plus 4 times 2, plugging 2 in for x, and then plus 4. So we get negative 4 plus 8 plus 4. So these two are negatives, and then we have 8 left over. So what were we doing here? We were finding k. So and that's it. So that's the h and k. We got the axis of symmetry. We could say that the vertex is a maximum. We could answer lots and lots of questions about these. We could sketch a graph. Maybe we could plug in x equals 3 and then maybe x equals 4 to get a couple other points just for a slightly clearer picture. But the 2 questions I just asked, one because it's a new topic I haven't talked about yet, and the other one because k, it's important to be able to find k. That's one of the most important features, and we need to practice it a couple more times. But that's it. That's increasing, decreasing, and 2 more examples of finding h and k from a parabola that is given in ax squared plus bx plus c format. And that's it.